Hey guys, welcome to my channel and I'm back again with another really interesting coding interview question video, and this time also guys we are going to solve a LeetCode premium level question, that is question number 422, valid word square. So let's get started with the problem statement. So basically guys, the problem statement says that we are given an array of strings and that is called as words. We need to return true if it forms a valid word square. And this definition of the valid word square is that it is a sequence of strings, that is the kth row and column read the same string. So for example, you can see that this is the matrix. So you have got the rows which I am counting like this. So ABCD is a row, BNRT is a row, CRMI is a row, and DTYE is a row. And the vertical ones are columns. So ABCD is a column, B and RT is a column. But if you compare the first row ABCD and the first column is also ABCD, and similarly the first row is B and RT and the second row is B and RT and the second column is also B and RT. And basically if you transpose this matrix, you will actually end up having the same matrix. So if at any position the row and the column, if reversed, give you the same string or the same letter, that means that this is a valid word square. Same is with example number 2 as well. So you can see here that what is happening is all the words are not of same length, but still if you look at the first row, you have got ABCD and the first column is also ABCD vertically. And same, if you see the third row is called as CRM, which is a smaller row, but the third column is also CRM. So there is a box which is empty. And same for the last one as well. But if you have an example where this doesn't match, then you just have to return false. So you can see here the first row says ball, BALL, but the first column says BARL. Okay, so this R is not equals to this L, and hence this is not the right square, so we return false. Let's look at the constraints, guys. The constraints are the length of the words go from 1 to 500, and again the words in the column wise length also goes from 1 to 500. Words only contains lowercase English letters. Okay, so that was the problem statement, guys. Let's look into the solution approach. So basically guys, this is a simple matrix problem, but we are just given a string instead of numbers. So what we just have to do, that let's say this is your word, and if you access each and every character of your word through row and column. So let's say this is the character of the word row, and this is the column. Okay, and what I have to just do, I just have to check that if I reverse this, that means if this word is first accessed through column and then accessed through row, and if this value is actually not equals to this value, then it means that this is not a valid word square. Otherwise it is a valid word square. So if I try to now create my word, so each and every word is actually created row wise, right? So you start reading from here, from left to right. But if I start reading my words from top to bottom, then it means that I am actually reading my column first. So let's say this is the 0th column, and then this is the 0th row. So then you just keep increasing the column, right? So column is now 1, so you read the ABCD this, and then column is 2, you read this, and then same, right? So if your row wise word is not equals to your column wise word, then it's a problem. Okay, so let's say I start from my column, I take any column and I read all the words in that row, and then I start from any row and I read all the words in that column. If it is not equal, then it's a problem, right? So in short, this is a simple matrix problem. How do we resolve it? It's just very simple. All the matrix problems, guys, just remember, almost all of it just need a two loop approach. So you just have an outer loop. So you have an outer loop which will actually go from 0 until the number of the rows. Okay, so number of rows. Okay, what is the number of the rows here? So guys, number of rows is nothing but the length of the list. So whole list of words, so this is the number of rows. Okay, so basically length of the words array or the words list. And then what you do, you always do an inner loop. So you are using a two loop approach, so you create an inner loop here. Okay, So let's say you are in an outer loop, right? So you are at 0th row right now. If you are at 0th row, can you access the word horizontally? And the answer is absolutely right. Yes, you can. So if you just do word and then you keep your row here, then this is your row wise word. If you want to put it like these columns, you can do that, but it's not super necessary. But this is basically your row wise word, right? So I can make it row wise word, right? Now when you go into the inner loop, you have to make sure that the number of row that you just read, you have to now read that same column with the same index as that of your row. Okay, so now you will run an inner loop, but in this inner loop now you will access the column which is having the exact same index as that of your row. So here to create the word which is vertical, so let's say this is your vertical word, what you have to do, you have to find out first of all the length of the word that you have just created row wise, right? Because we are assuming that our column wise word will have the same length as that of my row wise word, right? This is what we are assuming. So we will basically run a loop from 0 until the length of my row wise word, right? Length of my row wise word, because I am assuming that this is going to be the same length. Now at any point on time, now I am running this inner loop, right? Let's say that this inner loop is with a index variable called column. Okay, so this inner loop is with an index variable called column, and the upper outer loop was with an index which is called as row. That is how you were able to access the word, right? Like word, and then in the bracket you mentioned the row. So this inner loop is with a variable called as column that is going from 0 until the length of the row wise words, from 0 to ABCD basically. But instead of reading the row wise word that is like this horizontally, I will now read the word vertically. Okay, I will now start reading my word. Here I will now take my word, but I will start reading it vertically. Okay, and how do I do that? In that situation, what will I do? I will now write the column here. So column will become first and the row will become second. Okay, because you can see that the column variable is actually incrementing, right? So column goes from 0 to n, but the row remains the same. In that situation, I will access the exact same column but vertically, exact same row but vertically. So if the row is 0, so this will remain 0, but the column keeps increasing. So we are going from 0, 1, 2 and 3, from A to B to C to D. So eventually I will have my word, let's say a temporary word, that will be now read column wise. Once this inner loop is completed, all we have to do is check if this column wise word, or you can just name it column wise word, if this column wise word is actually equal to the row wise word. Okay, so if this column wise word is actually equals to the row wise word, if this is equals, then you return true. If this is not equals, you return false. But there is a catch here, right? The catch here is that when you are running an inner loop and you are trying to construct your word, you have to make sure that this column and this row value are actually legitimate. If this column and this row value is not legitimate, then it is a problem, because we know all the words are not of same length. So it is possible that your row might have a bigger word but the same column might have a smaller word. So before doing this, we will always check that if the column is having the length which is less than the length of the row wise word. Okay, row wise word, right? So length of the row wise word, basically row wise word. And we will also check that the row should be row should be also less than the length of the word that we have picked through the column. So if this is the column, right, if this is the first column, then the length should be less than that, so that these two values are actually legitimate. Now if these values are legitimate, this word will entirely be constructed, and if still it is equal, we will be okay with that. But if this is not equals, we will simply do an early return and we will return false. In either situation, we will come out of the outer loop and finally we will return true. So all the matrix problems, guys, can be solved with a simple two loop approach. Okay. Now we are done with the problem statement, guys. Let's look into the coding part. For that, I have already submitted my code and I will show that code to you in a moment. So this is my code, guys. You can see I will just copy this out and I will try it out with you. We'll also go through it line by line. So basically, guys, you can see that I am going first of all through the row, and each and every row is accessed by looking into the length of the word list. So this is why it is length of words. Now we will construct our word, but this new word is going to be the column wise word, and for that construction we will now start iterating through the columns, and each and every column is again going through the length of the again each and every column have to be actually this column wise word actually has to be the same length as that of the row wise word. That is why the column iterator has to be in the range of the length of the row wise word. Okay, so this is words row, so this is a row wise word, and we will go through the length of the row wise word like here, right? So now we have picked our column. Now we will just check if this column is less than the length of the words, because now column becomes the row and the row becomes the column. Hence, column should be less than the length of the list of words, and the row should be less than the length of the word itself, the whole column word itself. If this is true, then we will just do the reverse. We will do words column row, and this is how you transpose the matrix. The column becomes the row becomes the column. You add the letter into your word, you construct the whole word in this WD. If this new word is not equals to the row wise word, this is a column wise word and this is a row wise word. If this is not equal, we return false. Otherwise, we return true. Let's run this code, guys. Let's see if this works for our problem statement. You can see it definitely works. And now let's jump into the okay, so you can see that it is accepted. Now what about the time complexity? So you can see, guys, the time complexity is definitely order of n dot m, where n is the length of the words and m is the number of n is the number of words in the list and m is the average length of the word. Now let's look into the space complexity. The space complexity is here obviously we are constructing a new word here, guys. Okay, so you can see that I'm constructing a new word to actually compare my word, and if I say that the new word's length, so every word length is m, so I have to say that the space complexity here is also order of m. Okay, so this is how we have resolved this problem, guys. You can see that it works in our case. I hope you like this video, guys, and I hope you learned something from it. If you have any better solutions, any questions, comments, suggestions, feedback for me, please do write in the comment section below. If you do like this video, guys, then please do not forget to like this video and share this video with your friends. In the end, guys, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.